All right, good afternoon and happy Wednesday. Yeah, I had to look at the time. Yeah, I guess it's noonish. Happy lunch hour, and it is time to leak code for me. So I'm gonna do some screen sharing of the contest that I missed last Saturday. So my kids have been playing soccer lately, so I haven't been able to participate in the contest live. So second best is to participate in the contest virtually here in hindsight. So all right, cool. Here we go. So weekly contest 371. I'm gonna jam on this one. Here we go. It's 12:35 in the PM. We'll open these guys up. Oh, these are always interesting to see these ones and twos. So this should be fun. Let's see, hold on. Let me before I start reading, I'll keep track of where we're at so I can see where I spend most of my time. 12:35 in the PM. Bitwise XOR is the maximum along strong pairs. N is small, so we should just be able to do a brute force all XY pairs. So the absolute difference is less than or equal to the minimum of the pair. We want the maximum XOR of those. Okay, well, it sounds like just two transformations, right? So let's say, okay, we'll do a filter for strong pairs. So this is a game plan. Let me write this down real quick. Oops. Game plan on filter. Oops. Filter all. We'll just call them IJ pair. Or we'll call them XY, whatever pairs. I like IJ instead, but we'll just force myself to do different characters just to change it up a little bit for novelty. All right, filter all XJ pairs of the input array A such that do the concave constraint, right? We want X, Y's absolute difference to be less or equal to the number of X and Y. Two, right? Go through all strong pairs. Oops, we'll just say this is strong pairs. Go through all strong pairs. Calculate their XOR, tracking, and returning best. So this would be useful actually for when I post this to the discussion board, I suppose, right? So here's the game plan. We'll see if it changes as the implementation goes along here. But basically what we want is our best, which will return at the end here. And then for our X in A, and let's keep track of the ith, jth index, just so we know that X and Y are a different pair. Right, that should be fine, right? Whatever. JY and enumerate. Oops. And there's a lot of ways to do this, right? Maybe I'll change this up a little bit. If I does not equal J, basically it's a different IJ. Oh, wait, we don't want pairs backwards, though, do we? No, we don't want pair backwards. So hold on. Let me just change this. Hold on. Okay, I wasted a little bit of time, but whatever. It's 12:38. Oops, let's keep track of this. The implementation begins somewhere around here. So read the problem statement and all that. Come up with a game plan. It takes a couple minutes. Okay, this is actually going to be better. Let's do N is the cardinality of array A. And then, oops, don't want to care for pairs backwards. So we'll just do this. Yeah, I was having a funny feeling that code was like just not feeling right. Hey, this is cool. Okay, so for hij pair, X will be a sub I and Y will be a sub J, right? So if okay, ij, I'll just say this is a problem case statement constraint. Okay, is lambda ij is input, and we'll say a sub I, oops, the absolute difference between a sub I and a sub J is less than or equal to the minimum of a sub I and a sub j, where a sub I and a sub j are x and y correspondingly for the problem statement. So if it is okay, then we'll say this is a candidate for something we call strong, right? Strong will be this guy, s dot append, and we'll say these are the strong pairs. Oh, okay, we'll XOR them right here then. Instead of keeping track of them, we'll just XOR them right there. Okay, so we'll do candidates. will be a sub I XORed with a sub j, and then best with maximum of itself and this candidate. Okay, so that's the implementation. Run it on these 7, 0, and 7. Looks good. Submit. It's a hit. 12:39 in the PM. Oops. This is about 4 minutes for the implementation in Python 3, which is accepted. Yay. Okay, so that's cool. Right, nothing too fancy. Let's write this in the other languages here real quick, and then we'll move on. A few solutions, and please do let me know if y'all have any questions about this. And I just post those questions here on the discussion board under my post. This is meant to be helpful for not only myself for practicing the syntax and semantics and some of this problem solving, but also I hope this is helpful for others. A lot of this stuff is pretty tough, the algorithms and data structures and such. And I feel like a lot of the examples are given that aren't really that helpful. So these are intended to be helpful, right? So cut through all the stuff and fluff and such, and then just focus on the meat, right? So something concise and simple and helpful, hopefully. Okay, so yeah, but what do I know, right? And I don't solve all 4 questions in the LeetCode contest. At best, usually I do 2 or 3, right? And you can look at my contest history as well as my ranking. I'm like in the 1800s, so what do I know? I'm not enlightened, right? I have a lot of room for improvement, so I'm not sure who watches these things, but my intention is that these are helpful, right? Okay, so let me keep going after here. So I'm going off on a rant here. And this is the cardinality under array I, oops, initialized to 0. Oops. Okay, then for j, initialized I plus 1. J is less than n, j, if okay, ij. Then we'll say the candidate, so just do this. Since I don't care for the squigglies for creating a candidate, we'll have an implicit candidate here, which is a sub ix or a sub j. Right, so if someone's reading through these solutions and you get down to the C++ solution and they're not able to make that correlation, then something's seriously missing, right? So these all will have like the basic same structure, right? Something simple and concise as I can make it in the same order, so they are corresponding from language to language. Right, here we'll return the absolute difference between a sub I and a sub j is less than or equal to it's less than or equal to the minimum, right? The minimum of a sub I and a sub j. I'm going off on right here, losing my thought process. What? Oh, okay, you gotta grab it by reference. By the way, this is okay for the C++ code is okay for LeetCode, but in production code, you most certainly would not want to capture all that information. And that would be based on this dude, the Scott Meyer guy. I'm not sure if y'all can see that, but the Scott Meyer dude wrote this thing called Effective Modern C++, and he talks about a whole bunch of goodies for C++. And a lot of it I don't follow in the context of LeetCode because it's extremely verbose, like const and stuff. In production C++ code, you want const pretty much everywhere that you can put it. As an example, okay, but I was looking at lambda expressions. Okay, yeah, lambda expressions. So item 31 of Scott Meyer's Effective Modern C++ says avoid default capture mode, and that's page 216. So yeah, avoiding default capture modes basically says avoid what I just did, right? So take what I do with a grain of salt here, right? So that ampersand basically grabs everything by reference, not just A. So in production code, you want to just grab A, right? So in production code, you want to just grab this guy, right? It works. It's more verbose, and it's one of the many things that is more correct and more verbose. So in the context of LeetCode, and I'm going to leave it out, right? So in the context of LeetCode, and I make a lighter, and the linter, I'll make that thing light up like it's Dwally. Okay. Yeah, before I go on more of a rant here, let's move on. I'd love to have more time for some of these other questions. So get some of this practice out of the way and we'll keep jamming here. So n is the cardinality, then for A, and then we'll go for I and 0 until n, and then for J and 0 until, oops, I plus 1 until n. Yeah, we'll use a implicit candidate for this guy too. It should be okay. If okay, ij, oops, best. This is what we'll return. Be the maximum XOR. Best is the maximum of itself, and a sub I XOR'd, oops, XOR'd with a sub j, if it's okay. Okay will be our lambda ij. Oops, it says that the absolute difference between a sub I and a sub j is less than or equal to the minimum of a sub I and a sub j. Okay. Big money, no whammies. Oh, yeah. So Kotlin is really weird with the bitwise operations. It's actually XOR. I'm gonna just hit submit. Oh, oh dang, what did I do? Oh, what happened? Oh, oops, this thing should return a Boolean. Wait, yeah, this should be okay, right? What's going on here? Abs, absolute. Wait, hold on, let me run this again. What? It is an int. Oh, oops, I want minus. Oops, this minus that. Oops. Yeah, well, I'm only human, so I'm gonna make mistakes. It could be worse, I suppose. Yeah, it could be better, it could be worse. Yeah, it is what it is, right? Mm, yeah, that looks pretty good. Yeah, so yeah, let me copy and paste my game plan that I wrote over here. Oop. Look at this. Okay. Be a strong pair. Let's see. Oops. Here. Brute force consider all ij, oops, ij pairs of the input array A. Let OK be a strong pair uh, filter function. Yeah. For the problem statement, right? All xj. Let's say this. I'm going to do a sub I, a sub j. I'll just copy and paste this. It's okay. It's kind of verbose, but whatever. Make it super simple if I can, right? You don't have to even map a sub I to X and a sub J to Y, right? So oops, this one's I. Just put a sub J, right? And you can see this in the code. Yeah, let's just make this bold. Put a little arm in here. How about, let's see. Yeah, this guy, strong pair. Raw. Are we gonna have a filter here? Oops, filter. Yeah. Wait, funnel. Cone. What I do? There we go. Consider all. Let's see. Let canned. I guess consider, how about this? Consider all, oops. Consider all candidates XORs. The strong pair, or the XOR of the strong pair. Find and return the best, the maximum as the best answer. Right, fine. A little verbose, but whatever. It's always nice to have a good, clean description, right? With proper English, pronunciation, or white spacing, words and such, right? Oh man, yeah. Some of the top voted solutions. I'm wondering what people see in those things. Like, holy cow! I often feel like it's the blind leading the blind. But again, what do I know, right? I still have a lot to learn. All right, so let's get going. Let's start rambling about that Amazon dude again. Man, Amazon is everywhere, even on my LeetCode. Seriously, I still don't see why people upvote their solutions. Ugh, whatever, if it's helpful and works for y'all, that's cool. Yeah, Okay, it was nice to focus on something else for a moment or two here. Okay, there's JavaScript. Then we'll do Rust and then move on. All right, shorten this thing up a little bit. It's fairly concise as it is, but whatever. I mean, just like a habit I got in. And I think it's gonna flow overall, especially when you have two-dimensional vectors and such. Okay, anyhow, we're gonna return the best here. Let me best. Best to be 0. Let's do this. Oops. The n, you do the cardinality n for a and for I n 0 until n non-inclusive, and for j n I plus 1 until n non-inclusive. If okay, a sub I sub j, just do ij. Feed entire lambda. Best equals candidate. Best is the maximum of itself and the candidate. So there we go. Okay, and then let's define okay. Oops, it'll take in the tuple ij, which is our ij pair, and return I minus j. It's an absolute value is less than or equal to the minimum. So I'll just grab min here. The minimum of a sub, oops, make sure we need to be a sub I, a sub j, a sub I, and a sub j, and something like that. Uh-oh, cannot infer type. Okay. Oops. Yeah, take two arguments like that. Not infer type. Type must be known at this. What? All right, well, let's do as I32, how about? Really? How would you not know this is an I32? Cannot infer type. What the heck is going on here? I'm pretty new to Rust, so I don't know what's going on. Usually it's just like failing forward slowly like that, like one compiler error at a time. Holy cow, Rust gives me a hard time. Like, why? How can it not know it's an I32? Like, what the heck? Is it like, does that make it difficult to understand? Like, I don't know. I don't see how that would matter. Let's see. It's extremely verbose and quite ugly, I think. Really? How can you not know what this is? Are you kidding me? It's an I32 minus an I32. So how do you not know what the type is? That's a little bit better, right? At least I don't have S I32 twice. All right, things that make it go WTF, yo. Rust is one of those things. All right, that's cool. Post that. All right, so brute force consider all a sub I, a sub j pairs in the input array A. One, let OK be the strong pair filter function. That is all a sub I, a sub j pairs of the input array A such that a sub I minus a sub j is absolute difference is less than or equal to the minimum a sub I, a sub j. And we consider all candidate XORs. That is all the XORs of the strong pairs to find them and return the maximum is the best answer, right? Okay, so there we go. That's good. And then what happened here? Okay, let's move on to Q2. Okay, so that's Q1. That took about 24 minutes. All right. Oops. Q2. Q2, we have about 1 hour and 6 minutes left. Means Q1. Oops. Q1 took about 24 minutes. Eek. Okay, we'll call that access times our array. And it is 12:58 in the PM. Okay. Okay, an employee in access time, 4 digits for 24 hours. Okay. 3 or more times in a 1 hour period. That would imply a sliding window. Okay, it's non-inclusive, 1 hour non-inclusive. Okay, they have to be part of the same day. In any order that we want. Okay, so we need to sort it by, wait, hold on, are they already, are within the same day? Then how could this be possible that their access times at the start and end of the day are not counted? What? Not part of the same 1 hour. Oh, it doesn't overlap in, okay, that makes sense. It doesn't overlap in the opposite direction. Yeah, okay, yeah, duh. Okay, it's 1 day and it doesn't overlap. Okay, that makes sense. Like I have to read that kind of close. Okay, it doesn't overlap in the opposite direction. Like it doesn't roll over, right? That's kind of silly. Okay, it's not inclusive. 1 hour, not inclusive. Okay, so 3 or more. Okay, so those are our filters. So let's get going. The game plan is 1:50 or 1 o'clock in the PM. So here we're going to basically do all this stuff, right? So this is just read and do it as the problem statement says, right? Okay, so our answer will be the high access folks. Yeah, right, just answer is cool, right? Answer. Okay, so we need to sort it by person by time, right? So A equals, or actually, let's just do this person and time. So let's do, we can do a map of a person, right? No, just go through each person, person time, right? If it's sorted, person time. Yeah, okay. Person and last. Okay, so we'll have two variables. I'm kind of doing this as I go, right? Just like do the problem statement. Right? What the problem statement says to do. Right, that's the game plan. All right, so we want to do the people sorted. So for call person, right, person's fine, and then time in the input array A sorted. Right, so if we sort this thing, then all these access times should line up, and we'll just keep track of the last person, the last time, last person, last time equals, I would just say some arbitrary values. Last person, last time equals person time as we iterate through this thing. Okay, and then we'll just check chunks of 3 as we slide. That sounds good. Okay, so wait. Yeah, we're gonna go through. Okay, let's just do this. Actually, hold on. I was thinking of it a different way initially, but now I'm thinking, okay, if we do, we still want to have it sorted, right? Let's do this. A dot sort. And we still want to do for each person. Wait, no. We want to do for, let's do N is the cardinality of array A. Right, so that would be how big the thing is. And then do for I in range 2, 0, and 1. 2, 0, 1. 2 to N non-inclusive. So say I, J, K, how about I equals K minus 1 and J equals or K minus 2 and J equals K minus 1, right? So we have these indices, and this is what I'm imagining in my head right now. might as well just describe it. So if anyone is following along, hopefully it's helpful. All right, so A is 0, 1, 2. Oops. Actually, might as well just use the real example 1, right? As an example, A is this thing. When we sort it, this one goes first. Oops, hold on, let me just take this. Sorted is this, right? This guy, that guy, this guy, or maybe I should say fellow person thing. Okay. So high access time should be just this dude, or A, not B, right? Okay. That looks good. Okay, so let's do begin and end will equal, all right, A sub I sub 1 and A sub K sub 1 as an integer, right? So it's a string. I'll cast it to an integer. So 24 o'clock, right? And yeah, it should be fine. 24 o'clock actually makes my life a lot easier. Right? Okay, so then if end minus begin is less than or equal to, or actually, oh crap. Okay, so no, this is not integer difference. This is hours and minutes, right? Difference. So I still do need to subtract the hours and difference, right? The hours and minutes. So the hour difference, 6 minus 5, so that's 1. But then the minute difference is less than that. Let's see, so I'm trying to get this in my head, but I might as well try to type it in as I go here so I can follow along, right? So the hour difference is 1. This minus that, but then the minute difference would be negative 11. All right, so negative 11. Come on, hour difference is 1. Minute difference is negative 11. All right, so the time would be 49. Right, 49-second difference. Does that sound right? 49. Count up. That's my guess, right? So we count from here to there. There's 28 seconds, right? 28 plus 21 is 49, right? I think so. That seems to make sense. 28 plus, oops, plus 21 equals 49, right? Yeah. Okay, so let's make a function. Create a function which calculates the time difference, right? We can't just cast it to an integer. So this is incorrect implementation, which I was initially writing, right? So it's not going to work, but I might as well just keep it here for breadcrumbs, right? It's not like I'm magically arriving at a solution somehow that popped into my head without any effort whatsoever, right? Okay, so yeah, there's no magic pill. But I guess, yeah, so yeah, we want it to be strings. I think having them as strings will make our lives easier for the function difference. Right, yeah. A sub I and A sub K will be the end of that triplet sorted. Okay, so if the function, just say it's a function again in the end is less than, actually, it exceeds the threshold of 3. I'll just say t is our threshold. T equals 3. Let t be the threshold. 3, right? It's basically how many, yeah. Or the quantity badge ins, or whatever we call badge ins. What do we call these? Access times within a 1 hour period to be considered access. That is part of the answer, right? This guy. Okay, so if that function is okay, or actually it exceeds our threshold, right? Meets or exceeds our threshold, then it's cool, right? We'll add it on to the answer. Let's just let the answer be a set. We'll just add on to it multiple times, whatever. We'll turn it as a list. Sure, add. Ooh, actually, we need to make sure these are the same to begin. These are the times. I need to keep track of the person though too. So if the person's different, we gotta skip them. A sub I sub 0. Okay, so I'll do, again, these are times and persons. May I call them Bob and Alice or Bob and Abe and Bob? How about let's call them Abe and Bob. Or how about this ABC? We'll call this dude ABC and this guy DEF. Oh, no, that doesn't work. That's a keyword. Okay. How about this? We'll call it mom and dad. How about that? Might be fun. Mom and dad. That could be any random people. It doesn't matter, right? Whatever. Not to my imagination. Okay, so if mom is not equal dad, we'll just say we're not part of the family, right? And that's basically like A being equal to A when this thing is sorted. I don't know. It's kind of stupid, but whatever. I'm just gonna go with it. And then if it makes no sense whatsoever, I'll clean it up here as I refactor. Okay, so if this thing's saying it's cool for the times, oh, actually, we don't need a threshold. This is stupid, right? Actually, the threshold is implicit here. I is the first of the triplet, J is the second of the triplet, and K is the third of the triplet, right? Actually, let me keep track of this because first, dude, second. It's kind of weird to look at, but this dude's third. IJK. Mm, if it looks better like this, and you see this guy's first, this dude's second. It's not lining up well at all. This dude's third. Hmm. Not sure if that looks nice or not. Yeah, whatever. Things complicated or not, but okay, well, try not to. Needs to be less than or equal to 1 hour, right? Hour difference and minute difference. Okay, so let's return the hour difference and the minute difference. So if the hour difference is less than or equal to 1, then a minute difference has to be less than or equal to 0, right? Let's do this. So, okay, hour diff is less than or equal to 1, and minute difference is less than or equal to 0. I think that makes sense, right? Or this one's, wait, that doesn't work. So the hour difference has to be less. Okay, if the hour difference is 1, then the minute difference has to be less than 0. Okay, so hold on, let me go through this. If hour diff is equal to 1, then minute diff has to be less than 0. It has to strictly be less than 0. It has to be at least -1. Right, -1 I mean this case 914. Or wait, 914. Oh crap, hold on. Maybe I'm thinking of this the wrong way. Hold on, for example, 1, I need to keep track of this too. This one's like subtly tricky. Yeah, I don't want 815 and 915. I don't want those to turn up. So here, this is what I was imagining in my head is 0815 and 0914. Those should be part of the same. These ones should be part of the same too. See, hour difference is 1. Minute difference is -11. And it's okay. Oh, here the hour difference is -1, actually. This minus that. Hour difference is -1 in this case. We want it to be positive. Oops, let's do this, just start it up. Minimum difference. We want it to be positive now. All right, so this guy's bigger than that guy. Otherwise, if it's smaller than that guy or equal to that guy, then it's no good. Right? It has to be bigger. This guy has to be bigger than that guy. Oh, yeah, maybe instead of calculating the difference, just to say, let's do this. How about if our difference is -1, then okay, if minutes, right? First, we'll do begin minute exceeds, strictly exceeds end minute. Right, that's one use case. And here we say if our difference is equal to 1, then it's okay if the begin minute is strictly less than the end minute. Right, that's one rule for this case. Okay, what if this hours is difference is 0, right? Then we'd also need this as well. Begin minutes, it could be equal though too. Right, okay, so the last use case is if our difference is 0, then begin minute has to be less than or equal to the end minute. Wait, I know it's already sorted. Since it's already sorted, that must be the case. Okay. Since A is sorted, this use case is accounted for, right? As just our diff equals 0, right? The second half, we already know. I guess the second half of this use case is accounted for, right? It's our, right? This part is always true, right? So we can just, right, just check for our difference equals 0. Okay, so if the hour difference is 0, then we're good. Okay, so that should be my function then, right? So we'll just do def function. We'll have a begin and end time, begin, end. And so we'll take the first part, hour 1 and hour 2, we'll say is the integer value of begin up to 2, oops, the integer value of n, like the first 2 characters cast in int. In minutes, it'd be the same thing, but for the last 2, 3 onwards. Sure if I have this right or not. I could have it backwards. So don't quote me on this. We'll run it sometimes, do some printf debugging. Okay, but anyhow, let's see. We'll do if hour 1 is equal to hour 2, that means the difference is nothing, right? Then we know this one's good. Okay, so this is this use case. So let's say return true. So if hour 1 is less than hour 2, that would be the use case where this guy. So then we'll return true if and only if the begin minute exceeds the end minute. Oops. And then if the opposite direction, oops, H1 exceeds H2. Here, I want to have these line up so I can see it a little bit better. It's the opposite, right? These should be backwards. Right, so this is the use case for, this is the first use case for H1 is less than H2. Ooh, and the absolute difference between H1 and H2 is equal to 1, right? It needs to be 1 hour off. And the absolute difference between H1 and H2 is equal to 1. Like they're off by 1. This guy's greater than that. That guy's strictly less than that. I think that looks good. Okay, and we can short that up a little bit later too. So let's just call this thing okay. It's okay. The begin and end. Then we'll add. Let's just say we'll add mom. Mom is equal to dad, right? We're all the same person. I don't know, that's weird. Whatever. Okay, I think that works. We'll run it and see what happens. A, C, D, and B, C, D. That's what we're expecting. Oh, and in none. Oh, it's just in none type. What is none type? What do you mean none type? It should be returning a boolean here. Oh, otherwise return false. It's okay. Oh, actually, let's do this. Let's do this. And cover this here. So we have the redundant code. Otherwise return false. Same hour. We're good. The hour's off by one. Sometimes we're good. Okay, that looks good. Let's see what happens. Looks good. Yay. Okay, so 25. Holy cow, this one took a while. I think that's most of the contest. We got what, 39 minutes left. Let's see. So that took like 27 minutes. That really took a lot of concentration to get right. I feel like it's quite a few steps where it's pretty easy to make a mistake. All right, whatever. We'll take it. And actually, let's clean this up a little bit too, right? In hindsight, we can see there's lots of room for improvement, right? Actually, this function looks okay. Oh yeah. I mean, I could squish this up into one line, but I think that'd make it very obscure and hard to read. Begin and end are self-documented codes as well as hour one, hour two, minute one, minute two for the times, right? This looks pretty good. It's okay. This is pretty key though, so I might as well highlight this, right? Perform a linear scan of the sorted input array. I just make sure it's the same person. Dr. Jekyll and Mrs. Hyde, his mom and dad, I guess. Yeah, it's the same person. That man, that woman's a man, man. Like that's a Jude. Yeah. This is funny. I'm just gonna go with it. Whatever. Mom is dad. Arbitrary choice. Arbitrary choice. This is the constraint for the same person, basically. Have these comments line up, whatever. This is pretty funny. I don't know. Made too many emojis. That's stupid, right? Whatever. We'll go with it. Right. And what I mean by arbitrary choice is that we could just add dad too, right? That's what I'm saying. Like mom is dad is the constraint that I had. Right. It's still accepted that way too. Gotta when we could add them both since it's a set too, right? Haha. Oh, mom equals dad. Hmm. Yeah, it's one of those things that'll make you think. Yeah, whatever. Well, let's do this maybe. So doing the opposite, we'll just do this. It's self-documented this way, right? And mom is dad. All right. Person, same person constraint, get an end. And the reason I chose these is because there's three letter words, right? And they kind of match up in a line, right? So you can see the code, right? And again, this would probably make that launcher light up like it's Dwelly, but for the context of LeetCode, you can clearly see what's going on here. And I think it's helpful. So it's helpful for me. I mean, I got it right? I mean, that's cool. We got 33 minutes left. Okay, stop rambling and then let's get going. I mean, that's a pretty decent solution. Right, that's cool. Yeah, that's not too bad. All right. It could be worse, could be better, but it doesn't have to be perfect, right? Few solutions. Oops. Python 3. Oops. Okay. I did this in Kotlin, JavaScript. Oops. Python 3, Rust, C++. So make that line up a little bit nicer, right? All right. Yeah, I mean, it's good enough. I really want to tweak it, but I don't know. Yeah, I'm going to. Here, it just looks weird to me. I'm just going to squish this over a little bit so it doesn't, kind of get lost in the code. Like that's the first, second, and third dude. And then if they're the same dude, then we're cool. Right? It's pretty key that we're sorting this thing. Right? Okay. Same person constraint. A couple more. It's easier to read like this, right? I think our monitors are pretty big this way, so that 80 line constraint is a legacy constraint that I couldn't care less for. But we might as well go wide. Okay, yeah, this looks a little bit better, I think. Let's see. So this is before. Yeah, that's pretty nice. I like that. IJK here, you can see that. It's very nice. Let's see. This guy's the penultimate, the antepenultimate. Let's see. The ultimate, the penultimate, and the antepenultimate. Might as well write it down, I guess, right? Made it very explicit. Ultimate, penultimate, penultimate, Anti-penultimate, right? I don't think I'm making up these words either. I mean, let's see what happens. Hold on. Ultimate, ultimate, penultimate, and anti-penultimate. Yeah, these are real words, right? Yeah, that's what I want. Okay. Ultimate, anti-penultimate, penultimate. Okay. You can see these are the three badge swipes. All right, that's cool and whatever. All right, good enough. Let's get going. I'm getting like hung up on the nitty-gritty details. I'm gonna start focus on the trees and lose track of the forest. So, and my tummy's rumbling too. I want to get going so I get some food. All right. We got two. These are only 4 pointers. Holy cow, an 8 pointer. Well, if I was gonna do a contest, I think I'd probably jump on the next one next, real quick. But here, whatever. I'm not in a rush. I'll just take my time and improve my coding speed and accuracy and thought process and this and that and blah blah blah. Right? I have a lot of room for improvement, so I might as well do that. Let's do this in the languages here real quick, and then whatever. We'll savor the other questions for another time. It's cool. Uh, I've been leak coding for like 7 years now. So it's like, dude, it's pretty obvious. I'm not in a rush. Not going anywhere too fast. So might as well relish going slow and really get some of this stuff down pretty solid, right? So, do okay will be our function. We'll grab default access. We'll take the strings as reference for begin and end. Right, that thing will return whether it's okay. Then we'll sort the input array A. Oops. All right, that's pretty important. And for let's do auto IJK. Actually, yeah, let's change the Python code. I'm pretty sure I can write this a little bit easier to read, right? Hold on. IJK, let's do this IJK so it's self-documented, right? So you don't have to have this comment, right? You can obviously see IJK in we can write this in a way where the sliding window is a little bit easier to see, isn't it? IJK. I suppose we might as well start with I instead of having K at the end, isn't it? That's the least I can do, right? Do I in range n minus 2. So n minus 2 non-inclusive. We'll stop at n minus 3, n minus 2, n minus 1, reach j and k for I correspondingly. So that should be fine. Okay. And then yeah, that looks better, right? And let's do this, right? J equals I plus 1, and then k equals I plus 2. Yeah, there you go. IJK. Okay, this looks a lot better. Okay, that was really bothering me before. So hopefully, I don't know if it's bothering y'all too, then we'll get our heebie-jeebies out together, I guess. Whatever we want to call them, right? The spidey sense of crappy code. Yeah, I mean, I've been working in the software industry for almost 20 years. Like, holy cow, I'm old. By far the worst thing that can ever happen to me that's ever happened is working on crap code. Like, that is just absolutely the worst. And on top of that, if you're working on crap code, if you have to work with crappy people that won't even document or describe that crap code, like that is the absolute worst scenario you can ever be in. Holy cow. It's good to be in there though for practice, I guess. Almost like taking a trained dog to a dog park. Okay. Anyhow, you can't escape the mob. The mob is within us, all right. So what do I know? I'm doing my best to be a totally legit dude that's here to help myself as I help others. That's a legit way to live. At least I think so. So all right, whatever here. Okay, so this is better code, right? This is crap, right? My thought process was somewhat junk and disorganized. I had to kind of like describe it here. Code that's written well should be self-documented, but put little emojis over here on the right-hand side so we can see clearly this is a sliding window of 3, the antepenultimate, penultimate, and ultimate. Oh, okay, excuse me, and let's get going here. All right, that's cool. It's always nice to improve, right? We're all work in progress, right? So don't be too hard on myself or others, right? So it's 2, where n is the cardinal for A. What is the size of 2? It's at least 2. So we can subtract 2 from it. It's always sketchy subtracting from U size. Actually, let's just do this. It's way safer in C++ is just do assigned integer, especially if they're subtracting from it. Because who knows when the LeetCode is going to change the problem statement and it's going to cause test cases to fail. If n is 0, that is, and it's a U size, which is auto would be. If you subtract from it, it's going to be some gigantic number. Okay, yeah, before I start rambling on, let's keep going here. So j will be I plus 1, and then k is I plus 2. Oh, by the way, I should mention that j is not used, right? But j is used mainly as a placekeeper, right, for self-documented code, right? Code that is simple and concise is what I'd like to see. And I'd love to see that proliferate through the industry. Make my life easier, make your life easier, make everyone's life easier. Write good code, not crappy code. Okay, in here, we'll return the answer here at the end, and we're going to formulate the answer in piecemeal fashion as we go here. Right, so if okay, let's say begin and end, also check. Well, yeah, okay can check for if the dude's the same too. All right, let's make that additional constraint change. Right, so if you're going to debug this code, okay is the constraint which should handle everything, right? So this is an additional abstraction okay can handle for us on our behalf, right? So let me make that code change here real quick, iteratively refactor. So let's just say if okay I k. Leave all this stuff which is part of okay but not in okay up to okay, so the code is cleaner. Okay has 2 constraints, right? The person's the same, and might as well not even do that part, right? So let's do this. I and K. I and K. Okay, that looks a lot better. I mean, that's much better code, right? Oops, mom's not defined. Oh, I do need mom. Oh crap, okay. So well, like add if okay. Yeah, I don't know. How are we gonna get mom out of this thing? That's the problem right now. Yeah, sometimes when we refactor code, it ends up not working. So whatever, we'll just revert. Like some of the okay logic is here, but it makes sense to have some of this okay logic here, mainly because we need mom, right? Whatever. The okay logic is somewhat constrained, and this is the time okay, right? 3 badges. All right, yeah, let's stop fiddling with it. Let's get going, right? I'm gonna run out of time. 20 minutes left anyhow. 20 minutes left. That'll put us at 2:05. Okay, let's do this. Auto mom and dad. A sub I sub 0. A sub I. A sub k sub 0. If mom does not equal dad, it's the same person constraint. Oh, wait. Yeah. Okay. So hold on. I was thinking canon and we can just do this. If a sub I sub 0 does not equal a sub k sub 0, and just say that's the same person constraint. Right, but we need a comment though, right? I'm wondering if it's helpful to remove some of these ephemeral values now. Like, do we really need to call it mom and dad? That's just weird. Yeah, I don't know. Let's just do this. Let's just call it here. Let's just do A and B and whatever. Oh, now I'm. Oh, what did I do? Oops. Just leave it. Come on, stop fiddling with it. What am I doing? Totally wasting time. Come on, let's just do it the same way because we're later on we're gonna use it down below, right? So a sub I sub k, a sub 0, a sub k sub 0. Let's do this. It's a set. Don't want to add her more than once. Set of strings. Pass it to a vector of strings at the end here as we return it. Oops. Oh man. Okay. Here we go. Okay, so if it's okay, the second part's going to be the end, the begin and end. So hour 1 and hour 2 will be the substrings. Substring of begin, 0 to 2, end, substring from 0 to 2. The minutes, oops, be the pair. Substring 2 onwards, oops. I'll just explicitly say 4 just to make the code line up, right? I don't think we need it. Right, that should be sufficient just to do 2, but we're just going to use 4 just to make that look nice. And then if h1 is equal to h2, then we're good, right? Return true. That's cool. All right, so if the absolute difference between h1 and h2 is 1, then if h1 is less than h2, then it's okay if and only if the minutes are positive, right? This one's less than that one. It's backwards, right? So otherwise, if it's the other way, you return again the other way, right? I think so. Otherwise, return false. Does that look right? Same person. It's okay. 1, 2, 3. Okay, something like that, right? Oh. Oh, I need them to be casted to an integer as well. Stoy. Yeah. Oops, string to an integer, right? Oops. Okay, looks good. All right, that's accepted. 13 minutes left. Okay, so we'll mark this thing up so it looks nice. All right, hopefully it's helpful. And then I'm gonna take a break here pretty soon and eat something. I'm getting hungry. Haven't eaten today yet. Okay, line that up so it looks nice, right? And then line these things up so it looks nice too. Okay. I don't know, we might call these guys badge access times maybe, but might as well put a little comment here, right? Oops. We'll call it badge access times. Oh, that's pretty nice, right? Badge access times. Begin, end, badge access times. Begin is inclusive and end is non-inclusive. Okay, that looks pretty nice, right? So put a little comment next to okay, I suppose, too, right? Right, the antepenultimate is an ultimate batch access times. Okay, I mean, looks nice. It's pretty good. Yeah, it's cool. I'll add this one to the Python 3 solution too. All right, and I'm probably not going to have enough time to go on to Q3 or Q4. Q4 is an 8-pointer, so that one must be really tough. Holy cow. Haven't seen an 8-pointer in a while, at least. Okay, so here's Python 3. I wanted to add on this guy, make it a little bit more clear. Can and end. Let's just do this, right? Get rid of that ephemeral thing. It's kind of verbose, right? The comment's okay. Mom equals dad, we know that. Okay, this is cool. Let's do this. Stick this thing here. Oops. What am I doing? Oops. I think I already grabbed that, right? It's cool. Yeah, let's just do this. Mom equals dad. Oops. And it's okay. Let me just stick a comment in there, right? So we're gonna stick it in one line at least. Yeah, it should be okay. Where goes dad and okay. Same person constraint and 1 hour. Yeah, that sounds good. Mom, dad. Yeah, we can still stick this on a different line too, right? It's okay. Okay, a little bit cleaner. Let's do this guy here. Same person constraint. Yeah, might as well stick this on this line and then merge this. Oops. Yeah, that looks good. Yeah, you can see the same person constraints in the next line there. These guys line up a little bit, so it looks nice. Okay, yeah, that's cool. Python 3. Yay, a little bit more concise, right? No, that doesn't look good. White space is off. I'm surprised it actually worked. I thought Python would complain about indentation. Okay, that looks better. I perform linear scan and sorted in per A into penultimate, penultimate, and ultimate. Right, these are 3 batch swipes. These are the times that need to be less than 1 hour. Looks good. Okay, got 6 minutes left. We're gonna land somewhere around here. Let's see what happens. Get somewhere around here. I'm gonna take a screenshot, and then if I remember in a few minutes, I'll update it. Otherwise, we'll land somewhere around here, which is cool. Whatever. Contest 371. Okay, so yeah, might as well keep chugging along here. So that's Python 3 and C++. Yeah, I guess I can write a description. Then I'll jam on this in Kotlin, JavaScript, and Rust maybe later on. I want to take a break. I'm getting hungry. I want to describe this thing here real quick, right? So let's, okay, be a function which returns true if and only if the begin and end times are less than or equal to an hour apart, right? There we go. That sounds good. And then, right, then perform a linear scan of the input array A, or the sorted, right? Of the sorted. That's pretty important, right? Sorted input array A. Via a sliding window of size 3. I, J, and K. Right? Then add the person onto the answer. If and only if the A sub I person is the same as the A sub K person, and the begin and end badge begin and end badge access times are okay, right? I don't need to make that redundant. Okay, something like this then, right? Okay, let's see, how much time do we have left? We have 2 minutes. Okay, well, we got the first two questions pretty good, I'd say. Where was I? It's here, right? Yeah, run the description. Okay, a few solutions. Perform a linear scan of the sorted input A via sliding window size 3, right? Indices I, J, and K correspondingly. Is index I, J, K. Oops. Add each person onto the answer. Onto the answer, hands. If and only if the eighth or ith person is the same as the eighth and kth person, and the begin and end badge access times are okay. That is, the begin and end times are less than or equal to an hour apart. Okay, that sounds good. Wonder, good enough. And then Yeah, we'll do, oops, let's just do this here. I'll do this after I eat something. Kotlin and then JavaScript and Rust. Pretty sure Rust alone will give me a hard time. Huh. Okay, here's my to-dos. Yeah, that's cool. I mean, that's fun. That's good practice. In's not used, so yeah, I have some cleanup to do, right? What do I need to use this once for? Right. Okay, yeah, I'll do a little bit more cleanup probably too when I get back. A lot of these ephemeral variables don't make sense to have if you're only used once, right? So you might as well just do this straight up. I guess we do lose the cast, right? So we could do this. And for safety's sake, I get rid of in and then oh, contest ended. Okay. But it was a good thing I took a screenshot when I did. Otherwise, I would have lost that. So it'd be really nice if LeetCode could update that. It's pretty amazing to see like some of these folks what they can do. But it's always questionable. It's like, why would this dude submit these things like 10 seconds apart? Or this dude, why would this person submit them a couple seconds apart? It makes no sense whatsoever. And the only reason I could see why this would be done is if you have four people executing the code and then testing it in parallel. And then once you all did your own testing, then you submit it all at once. And I'm pretty sure I've seen this person screen share too, and I'm pretty sure that's what I see. It's like they take a screenshot and then like code all of them all at once in parallel. So sometimes it's questionable some of these winners, right? And some of these dudes look a little more legit. Like this dude seems pretty legit, this AWS guy. Anyhow, and what do I know, right? I only got two. So okay, got rid of in. Makes it a little bit better, I think. Okay, well, that's all she wrote. Catch y'all later.